Hello guys, today I want to discuss with you this important concept known as band theory of solids. And before we go further, let us have a look on this figure. This figure is for solid silicon. So this is just a part or just a piece of silicon which is trying to show the package of atoms within it. Remember, in any material, there are millions of atoms which just makes up that particular material. For example, even this mobile phone, within it there is a million of atoms which together makes up this mobile phone. So every material has millions, billions of atoms which compose that particular material. So here, this is just a part of silicon material, which within it now I have just tried to display some atoms which makes up that material. And here is a single atom, just a single atom of silicon, which exists in isolation. If I isolate, for example, let's assume this to be an atom of constellation, that we have considered this atom of silicon and we have tried to draw it here. So this atom of silicon is in isolation. It is not with the influence, it is not influenced by other atoms within a crystal of silicon. So as you know, silicon is found in group 4 of the periodic table. Within the periodic table, silicon is found in group 4, so it has a valence of 4, meaning that in the outermost shell of silicon, there are 4 electrons, and at the outermost shell, for example, here it is this one, so there is only 4 electrons in the outermost shell. Here is the first, the second, the third, and the fourth electron. So there are 4 electrons in the outermost shell of silicon atom. Remember, silicon atom has an atomic number of 14, so it is in the fourth group, and it is of 14 in number. And remember, when an atom exists in isolation, it means electrons within that particular atom are found in very specified energy levels. For example, here, this is the first energy level. This means that within the first shell of an silicon atom, there is energy level number 1. This is first energy level. So this corresponds to the first shell, and the second energy level corresponds to the second shell. And the third energy level corresponds to the third shell, which is the valence shell. This is in the case when atoms exist in isolation. It means when an atom is not with the influence of other atoms surrounding it. But in real sense, in materials, atoms are not existing in isolation. Atoms are there with the influence of neighboring atoms. For example, as we have seen this structure, it means if this is the atom of constellation, it is here, but it has the influence of other neighboring atoms. So atoms in real sense are existing with the influence of all surrounding nearby atoms. So if it is existing with the influence of other surrounding atoms, it means the energy levels will not be specified, will not be specific. It means the energy level of the atom, for example this, will be influenced with the energy levels of the atoms surrounding it. It means if it is the first atom, it means this is the second, this is the third, the fourth, the fifth, the sixth, and the seventh. So these are the atoms which surrounds this first atom. It means the energy of the electrons within this atom, will be influenced by the energies of the electrons within the surrounding atoms. So the energy may be either lower than this or higher than this. So instead of having a defined energy level, we are going to have a band of energy. We are going to have a band of energy. It means the energy which is not defined. Instead of having this, we are going to have either a lower energy or we are going to have energy higher than that of the single atom. So finally, we are going to have a range of energies. We are going to have a range of energy from this to this one. So here, now we have the range of energies. So here it is in the case when an atom is with the influence, is existing with the influence of other atoms surrounding it. And instead of having the energy level, it is now the energy band. It is no longer the energy level, but the energy band. The same will be for other energy levels. Also, the second energy level will be having a range of energies, be having a range of energy this way. And instead of being energy level, now it is the second energy band. Also, for the third, it will be the third band. The third energy band. So this it is in the case when the atoms are existing. An atom exists with the influence of other atoms. So the energy of electrons within this silicon atom, the energy of an electron within this single silicon atom is now influenced by the existence of other surrounding atoms within this solid silicon. Now, remember, the outermost shell is the so-called the valence shell. Also, in this bands of energy, the outer energy band will be the valence band. So the outer band, this one is called the valence. The valence band. It means it is the outermost band. Let us have a consideration on this now. Suppose this is a silicon atom. We have this silicon atom. And if this is now a solid structure of silicon, it's a solid structure of silicon. Within it, we have millions of atoms of silicon. So we have just assumed this only this 1, 2, 3, 4, 5, 6, 7, 8, 9. These 9 atoms of silicon within a crystal of silicon. Remember, each silicon atom has 4 outer electrons. So these are the electrons. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. For each atom. So each atom has 4 outer electrons. But when an atom now exists with other atoms, remember, for an atom to be stable, it should have 8 electrons in the outermost shell, or 2 atoms in the outermost shell. That's what we call the octet rule, or the doublet rule. So there must be either 8 electrons in the outermost shell, or 2 electrons in the outermost shell. But here we have 4 electrons in the outermost shell, and it is supposed to have 8 electrons in the outermost shell. So now, how does it become? How does it accommodate 8 electrons, while you can see here there are only 4 electrons. So what happens is the silicon atom must share electrons with the nearby nearby atoms. So here, for example, this is a silicon atom. So in order for this silicon atom to have a total of 8 electrons, it should share electrons with this silicon, also with this silicon atom, also with this silicon atom, also with this silicon atom, in order for it to have a total of 8 electrons. And it will appear as this way. It shares this way. Also it shares this side. Also it is going to share this way. Also this way. So by sharing this way, it means this silicon atom now has a total of 8 electrons. By counting, it is 1, 2, 3, 4. Also 1, 2, 3, 4. So it has a total of 8 electrons after sharing with the neighbor atoms. Also the same to these atoms, even this one to have a total of 8, it have to share with these nearby atoms. So sharing of electrons. Also this one here. Also this one should share this way. This one here. Also this should share this way. This one shares this way. Also for this atoms to have also a total of 8 electrons, it means this will share with the next atom here, also sharing with the next atom this way. Also this one will share with the next atom here, also will share with the next atom this way. So this will be the structure of silicon crystal, or a silicon solid crystal, after sharing of electrons.